Welcome to this Winemakers Research Exchange virtual sensory section. Today's topic is the accumulation of acetic acid during aging. In our discussion today, we will briefly touch on things like the causes, the thresholds of detection, and the sensory impacts of VA. But our focus is going to specifically be on preventing VA accumulation during aging. So I'm joined today by Lee Hartman, who's the winemaker at Bluestone Vineyards. Welcome, Lee. Thanks for sharing this experiment with us.
Thanks for having me.
It's great to have you. Let's start just by talking a little bit about why you wanted to do this experiment. Tell us a little bit about kind of how this got started.
So I've been making wine for about 15 years now, and something that we've kind of dealt with off and on and had to had years that were great and years that were bad, which I assume is fairly common amongst maybe some others in this meeting. I wanted to try to make sure that we were able to control VA accumulation. Sometimes you have barrels that after fermentation everything is tasting great, and then down the road, maybe it doesn't taste quite as fresh, or maybe it tastes a little muted, or maybe even worse than that. So we really wanted to make sure that we were able to consistently make a good, clean product without having to, either bring in VA removal or any other sort of alternatives, or figure out where in the world we're going to hide this wine in other wines. And if you can just avoid that to begin with, it would be a lot better.
Yeah, that's a great point, that it's much easier to deal with it, or at least to try to deal with it on the front end than to try to fix it on the other side. And I would just say that, you're not alone. So even though our viticultural practices have gotten a lot better so that we have less and less fruit coming into the winery that is spoiled, I would say that almost every winemaker that I've talked to still struggles with volatile acidity accumulation, at least in some batches and in some years, some vintages. So I know misery loves company, but we all, I think the sheer number of people that sign up for this session tells me that this is something that you are not alone with. So, much like many of our other, basically as winemakers, there's so many things in our winemaking operations that are sort of already baked in order to limit volatile acidity, both like basically from the time the fruit comes in to the time the wine gets bottled. So rather than like me listing off all of those things, I'm going to ask you as the audience to do a little participation here. So my question to you is, what do you already do to limit volatile acidity in your wine? And again, that can come from the time it hits your crush pad to the time you bottle it. And I'm going to just encourage you to maybe write that into the chat so that we can just get a whole list going. So go ahead and write in there, what is it that you're already doing in your practice to try to limit volatile acidity? And Lee, as that's happening, I'm going to kind of ask you to get us started. So, when we started this project, there were all these things that we talked about in terms of protocols that you were already doing. So tell us a few of the things you're already doing to limit volatile acidity.
Thanks. So some of it starts even before the fruit comes in. So we are about 95% estate grown. So, if any fruit doesn't look like it should go into a wine, I tell my team to either drop it or just leave it on the vine. And then, so when it comes in, we try to manage oxygen exposure from the time that it starts being crushed throughout the life of the wine. I understand that oxygen is a double-edged sword. It can be helpful in some circumstances and hurtful in others. So we try to be smart about that. We do use sulfur, and we're not afraid to do that, but at the same time we don't want to use sulfur more than we have to either. So we will add sulfur at crush or at the press, and we'll try to make sure that we get through mallow quickly if we're working with red wines or if we are done with alcoholic fermentation and we don't want to go through mallow on our whites, then we sulfur it again at that time. We also want to make sure that the yeast are not stressed out If you have happy yeast, then you can hopefully avoid some complications there. Maybe, and also, you don't want to feed your yeast too much, which is something that we should do a better job of looking at our YANs. You don't want to have a bunch of leftover nitrogen, which is something that Clark Smith talked about in Virginia like a decade ago, I guess. Other than that, trying to be as clean as possible. It can't just be, you can't just spray sulfur and citric on stuff. It has to actually be visibly clean, and it can't be sanitized if it's not clean. So we do that as well.
Great. So, and I'm going to say, Rebecca, can you see answers coming into the chat? I'm not able to see those, so maybe I'm clicking in the wrong spot.
No, I don't see any in the messages. If any, is anybody writing them in and they're just not going?
Yeah, so I'd say, audience, we need your participation here. So in addition to what Lee has just said, what else could be done? What else could we do to limit volatile acidity in the wine? So Rick, so thank you, Rick. So Rick says adjust pH. So that a lower pH is probably going to be a little bit more inhibitory to our microbes, and it probably will give us a little bit more molecular fraction to our SO2. Top. That's an excellent point. And that goes back to that. One of the ways we limit oxygen is when wine is aging, when it's in malo and when it's aging. It's just keeping things topped off so that the things at the surface don't have access to oxygen. Ketosan. So ketosan is something we'll talk about as we go through today, but definitely there's been uses of ketosan, soup to nuts at this point from the beginning and end of fermentations. Emily says ketosan and non-sac yeasts to start. Yeah, that's a great point. Using commercially available non-sac yeast at the beginning. There's all kinds of non-sac yeast now, but some of them are known to be or are marketed to be bioprotective, where they're maybe some of them actually consume oxygen at a pretty high rate. There's one of those now. Some of them are there to kind of hold space so that other microbes can't get access. Increased temperature. Increased temperature to go through malo faster. Yeah, malolactic fermentation is a time where sort of our wine is kind of unprotected for a long time. So going through that faster and being able to get things kind of topped off and sulfured is good. And especially if you're sort of lingering in the winter time, that's one of the things that might be prohibiting it from happening quicker. I have selective picking for sure, like making sure that you're not bringing those things in to begin with. Oxygen exposure, topping, and SO2s for sure. Malo-Coanoc. So Rick, that is an interesting point. We'll talk a little bit about Malo-Coanoc as we go through today. Maybe we'll kind of touch on that at the end as well, because that can really go either way depending on how you're managing things. So that's an interesting one. And then Jay says cleaner fruit to start, top barrels, and pH adjustment. Yeah, so these are all kind of things these are all really great ways to get started. And I think, as Lee said, these were things that were kind of mostly already part of Lee's protocol going through. So we'll kind of highlight those as we go. So you guys did a good job on that one. Bruce, did you have? It looks like you.
Yeah, there is one more point that we kind of ran across years ago. That's, I think, somewhat counterintuitive to some winemakers. Cold cellars can inhibit the growth of many organisms, but they also increase the solubility of oxygen. And if we're talking about Acetobacter, acetic acid bacteria, and Gluconobacter, we're talking about aerobic organisms. That is to say, oxygen-requiring organisms. So the most importantly is that the rate of phenolic activity slows down tremendously when you have the cellar cold, and cold I would define as anything below about 59 degrees. And this phenolic activity, specifically, without getting too geeky, the binding of the diphenolic cascade, which essentially binds up the oxygen and prevents that oxygen from either oxidizing components or, in this discussion, from being available for aerobic organisms. So that's just keeping your cellar cold doesn't necessarily prevent the growth of oxygen requiring organisms, particularly when that wine warms up, because again, of the increased solubility. And this diphenolic cascade is particularly important for something like Pinot Noir, but it's also relevant for any other variety, red variety, because the cascade difference in its ability to bind up the oxygen from, say, 59 degrees to 50 would be about 30%. And so binding up the oxygen is a way of preventing aerobic organisms from growth.
Yeah. Yeah, that's a good point. The role of tannins in sort of both its role in oxidation and sort of binding up that oxygen so that it's not available to our spoilage microbes. It gets very complicated as you kind of start going all those different ways. But that's an important point. Thank you, Bruce. So I would say that, with volatile acidity, there's lots of things that we sort of target our WRA trials against that we really can't measure with a lab test. Like, I want to increase minerality in my wine. There's not really a lab test that gives us that. But with volatile acidity, there are lab tests. It's kind of part of a normal panel. So the next question that I have for the audience, and the same thing, if you want to just write that into the chat, is, when you're doing your lab testing and you get a VA number back, what is sort of the alarm number when you're like, oh no, I might have a problem? What number are you looking at? Are you looking for to say, oh, I really need to pay attention to my volatile acidity at this point? And as you guys are writing that into the chat, I am going to just do a really quick review just to make sure that we're all sort of talking about the same thing when we're talking about volatile acidity. So let me go ahead and share my slide here. Okay. Are we good on sharing there? Okay. All right. So, oops, that doesn't work. Okay. So, as you guys are writing into the chat, what is your alarm number for volatile acidity? What number should we be looking out for to say, oh no, we're in trouble? As you do that, we'll, like I said, we're just going to kind of define a couple of terms here. So when we're talking about volatile acidity, we kind of want to make sure that we know what we're talking about. So if we look at sort of a definition, a lot of the definition in like the textbooks and that sort of thing are very technical, but I found this definition I thought was kind of a good one to keep in mind. This was from Jamie Good in his book Faultless. And he calls it the portion of total acidity that's released as vapor at room temperature. And basically that's the part that you can smell. So any of our definitions of volatile acidity are sort of in conjunction with, there's the total acidity of the wine. You have your fixed acids like your tartaric and your malic and your lactic and that sort of thing. But then you have this volatile portion. So the fixed ones stay in the wine, and this volatile portion are the ones that sort of at room temperature might essentially volatilize. And that's why we can smell them. In a little bit more technical sense, that is the steam distillable acids that are present in the wine. And that gets to how we sort of normally are probably measuring those. And that's traditionally kind of with a cash still, that's steam distilling them and then titrating back. When we think about what's included in the volatile acidity of the wine, most of the time we sort of talk about the acetic acid, and that's the portion that, smells like vinegar. That makes up, in a normal situation, that makes up about 93% of the total volatile acidity of the wine. So most of the time, that's the majority of our volatile acidity. But there are other components to the volatile acidity. And, I was talking to Ken Hurley, who used to run the Virginia Tech Lab. And he said, the thing, like, for example, with the FOSS system, it's calibrated against standards for acetic acid. But if you get sort of more spoiled wines, you get more of these other components along the way. And so the relationship between what that number is going to give you and what the true volatile acidity is, based on if you were really doing the distillation, starts to drift a little bit. So we do need to remember that a lot of our labs are really measuring acetic acid, not necessarily volatile acidity. And for the most part, that's pretty valid. There was a test done by AWRI where they looked at more than 350 wines, and they found a really strong correlation between those two numbers. But again, when we start to have more spoiled wines, that correlation is maybe not as great. And then there's one other part of volatile acidity that I'll say kind of might change how we're reading this number that we might be seeing. And that is the impact of ethyl acetate. So ethyl acetate isn't technically part of the volatile acidity of the wine. It's not actually an acid, but its presence might contribute to the sensory impact of volatile acidity. So if we've got ethyl acetate kind of above threshold levels, then we're probably that volatile acidity number that you get back. The wine might seem sort of more like it has more VA than what the number might be telling you. So that's not something that's included in your test, but it is something to be aware might be impacting that. Okay, so let's see. I only have one number here for volatile acidity coming back from the lab. So if I'm, again, if I'm worried about VA, what number am I looking for? So I see a 0.75, I see a 0.7, I see a 0.8. I see Emily saying it depends. So Emily, tell me if you're, if it depends on the actual number, if it's white or red, what is it for white and what is it for red? See if that comes back. Okay, when is it actually spoiled?
So for me, it also depends on time of year, because if I get a 0.5 and it's the first time I've checked, I'm more worried than if I get a 0.5 at the end of the season. But for whites, I 0.8 or 0.7 for a white, especially like a Sauvignon Blanc, that would be very stressful to me. So I have kind of ranges for all of those numbers. And then of course, then we have Petit Manseng or late harvest Petit Manseng have much more tolerance with higher VA numbers, because they're less perceivable aromatically, even though they are, greater than 0.7 or 0.8, they don't show as well as say a 0.7 in a Sauvignon Blanc. So I guess Bruce trained me well. Like it depends, I guess, on which wine you're looking at. But I would agree with what a lot of people have said, the 0.7 or 0.8, to start, especially in reds. If that was my first VA post fermentation, post ML, I'd start looking at that pretty quickly.
Yep. Yeah. And I think that's a really good point. And I think, when you look in the textbooks, we see basically it does depend, but a lot of times the sort of textbook number and comes up somewhere around 0.7, in the sense that sort of below that, the textbook will tell us it doesn't really impart too much spoilage character to the wine. Somewhere around 0.9, it sort of will give us some noticeable problems, even if it might not be specifically acidic. And somewhere between 1.2 and 1.4 is sort of when it's going to be like, oh, this smells and tastes like vinegar. But as Emily just very, very, very well said, that there's lots of other things that impact the sensory character of like how much that's impacting. So again, we already said if we have elevated ethyl acetate, the number there is somewhere about above 150, although maybe above 90 or so, we start to get a little bit worried that 0.7 is going to seem more volatile, like we have more VA than if it's less than 0.7. But then there's other impacts of these things in addition. So there are a couple of studies now that are showing that it does, like acetic acid itself, at levels as low as 0.4 can start to decrease the impact or the perception of fruitiness and wood character, even before you kind of perceive it as VA at all. And this gets back to what Emily was saying about white wines. If you have lower pH or higher acid wines, your VA is going to be more apparent. So that, that's where it's like maybe in a Sauvignon Blanc, for example, if you get to like a 0.5 or a 0.6, you start to recognize or see it. And then wines that have higher alcohol levels, like our Petit Verdot, or higher sugar levels, like dessert wines, those are going to tolerate a little bit more before you actually recognize it as VA, or probably and maybe the Petit Manseng goes into that as well, right? Petit Manseng has a lower acid or lower pH, but it also has that high alcohol and that perception of sweetness that maybe means that we can tolerate a little bit more. I do see this question that Pete put in there, has anyone cross-validated volatile acidity as measured by Sentia, FOSS, and a cash still. Pete, I don't know yet if we've seen those. We have done a couple of validations with Sentia, but we haven't done acetic acid yet. That is on the short list for some of the things that we'll do next. So maybe once we get through the first couple of sensory sessions, then we can address that. I will say that the FOSS wine scan, I think the initial numbers were validated against the cash still, like the calibrations for the FOSS wine scan themselves were calibrated that way. But again, we know that that is somewhat dependent on the matrix of the wine as well. And so, and yeah, as Bruce says, the matrix can have a large impact as well. So, okay, so you guys did a great job with that. Bruce, did you have something to add there?
No, thank you.
Okay, great. I'm sorry, I just saw your face popped up. So, and just to sort of orient us to where we are sort of relatively in Virginia, I think a lot of times we think we have super high VA wines. This is just a survey of volatile or of acetic acid. So the measure we use is specifically acetic acid in WRE trials in the last 6 or 7 years. And this I think just sort of drives home what we were already saying, is that, you know, our red wines do tend to have more acetic acid, but they also tend to tolerate more. Our white wines have a little bit less, but again, they might show it a little bit more. Today, we're going to be looking specifically at a Cabernet Sauvignon and a Cabernet Franc. And if you look, Cabernet Franc is, let's see, no, there's a little tool where I can mark this up. Here we go. So this one is Cabernet Franc, and this one is Cabernet Sauvignon. And if we look at sort of a 0.7-ish would be about here. So we can notice right away, Cab Franc has quite a large range, but we also have more of those. Cab Sauv, the average is a little bit higher. So just keeping that in mind, that, you know, we're kind of right around that threshold of detection almost before we even get started. And as we've already touched on, you know, there is a certain amount of acetic acid that's going to accumulate based on kind of normal fermentation. So Saccharomyces does make a little bit of acetic acid just in normal processes. Usually 0.25 to 0.36 is the number I found. We also have a normal accumulation during the course of malolactic fermentation. So your wines that go through malo will have higher VAs. The wines that don't go through malo. And then again, just aging in barrels, there is an inherent amount of just oxygen that's in the pores of those barrels. And we do get a little bit of non-enzymatic oxidation. Doesn't have to do with spoilage. It's basically just because that oxygen is already there. If you kind of do some quick math and add all of these up to say, well, if I'm kind of, you know, when I'm finished with malo, when I'm finished with fermentation, kind of what's a good number? We add all of those up, including the aging number, we get somewhere between about 0.4 to 0.7. When we start to see elevated values, there's lots of different places that might be coming in. So it could be coming, as Lee touched on earlier, just from stressed yeast, but we could also have any number of kind of spoilage microbes that might be happening during alcoholic fermentation. And we'll look at a couple of those as we look at some data in just a minute. We may have, again, malo is a common place to do that because our wine is not sulfured yet. We no longer have kind of as strong of a CO2 blanket. And as much as other lactic acid bacteria might also consume malic acid, the reason we tend to use Enococcus is that it produces less acetic acid than some of our other lactics might do. And then during aging, we often think so much about Brettanomyces, which certainly can consume any sort of unfermented sugars, and it can even sort of release sugars from the wood itself. But acetic acid bacteria is probably as important, if not more important. And in that case, we just need to think about the fact that anytime there's oxygen available, those acetic acid bacteria are nearly ubiquitous at any stage. And so we do need to just kind of be thinking that those guys are always there. Okay, so with that, we can jump into our experiments for the day today. So, you know, again, Lee said the whole idea here was to say, how can we improve wine quality by just keeping this at bay as much as possible? So we really had kind of two goals here. One of them was just to track acetic acid accumulation in order to look for critical control points. And then the second was kind of to test two specific interactions to see if they were affecting affecting acetic acid accumulation during aging. So Lee, at this point, I'll ask you to come back into the conversation. The first experiment we're going to be looking at today was the one with your Cab Sauv. So tell us just a little bit about Cabernet Sauvignon at Bluestone. How important is this to the kind of the line of wines at Bluestone? You know, how does it compare to your other wines? Tell us a little bit about your Cab Sauv.
Sure. So without I don't know that I should assign a reason to this or anything, but at Bluestone, of all of our dry reds, Cabernet Sauvignon is consistently the most popular. We sell more of it than anything else. It does not matter if it was a good year or a bad year or anything else. And I don't know if it's because here in the Valley, there's less of a wine culture, and so people gravitate towards things they know or names that they recognize. But we sell a lot of Cab, and you know, even in those years that Merlot might be a more consistent one, or Cab Franc might be, or Petit Verdot. Anyway, it is not always the best wine, though, is kind of what I'm getting at. And so part of that has to do with, like, in 2024, we had a really nice dry season, probably too dry. And then we had several hurricane and rain events during harvest. And so when your fruit is the last thing to ripen pretty much every year, coming in about the same time as Petit Verdot, but without those small berries and really loose clusters, you can run into some much bigger issues with VA accumulation. So that's why we really wanted to focus on Cabernet Sauvignon for a project like this.
Yeah, it's a good option. And one other thing I would say, you tend to age this like a year and a half in barrel, right? The one that we tasted today is a 2023. So,
yeah.
You know, that's, again, it's, you just have longer time that you're there, that if there is something that's going to happen, it has time to happen.
Yeah, and this was bottled a month ago, and typically we like it to go closer to 2 years. You know, if it wasn't for inventory reasons, we would have probably bottled this late spring or into the summer of this year. So,
yeah, exactly. So in there too, it's like when you kind of finish Mallow, your time clock still has a long way to go. So it's a good candidate for this kind of interaction. So I'll say just a little bit about the setup of the experiment itself, and this is going to be the same for both same general structure for both experiments. In this case, the grapes were just destemmed into T-bins. We did grab some chemistry and microbiology at that point. They were allowed to go through fermentation. Once they were pressed off, then they went into barrels for malolactic, and in each case we had 6 barrels total in the lot that we tracked. And in this case, 3 of those just got sort of the normal standard protocol, which at Bluestone is to get a good strong SO2 hit right up front. And then the second set of barrels still got that SO2 hit, but also got treated with Hideki tannin. Lee, do you want to say just a little bit about the 100 parts there? I think that's becoming more of something people are doing more and more, but that's something that you really seems to be working well for you.
Yeah, I am. To anybody who works with me closely, my ADHD is just an absolute joke to everybody. So for me to try to stay up on top of running labs on where's my SO2 at the moment, you know, over vintage to the next vintage and all that. There was a WRE project that kind of prompted this a number of years ago, where, you know, instead of adding 30 or 40 or 50 parts post mallow, you know, what would happen if you just added a much bigger amount, and then you did another barrel that was also the same total at the end, but it kind of ticked up, and so we just decided to make it a big add up front, and then to kind of not worry about it, particularly for these reds that have a higher pH and are going to last for a while in a barrel.
Yeah. And we'll see, and we'll be able to kind of watch what's happening there too. They get one big hit and then you don't add after. I will say that thank you, David, for pointing out, we do have a typo on the slide there. It's not 10 grams per liter, it's 10 grams per hectoliter. So yes, we did not put 10 grams per liter in there. So, and I would say that so if you're not familiar with Hideki tannin, I'll give you just a quick little overview. When we started talking about doing this project, we were mostly interested in using Stab Micro M, which is going to be the second flight. But the Enartis rep, and I don't remember if it was Michael or Tyler at the time, but they said, maybe try Hideki as well. So Hideki tannin is basically, obviously it's a tannin, and we know that tannins do have some antimicrobial properties to them. Or at least some tannins might have some antimicrobial properties. They are sort of part of the defense mechanism of the plant. And we also know they have some antioxidant properties to them. So, Enartis developed this product as kind of one of the things that's part of their low SO2 winemaking arsenal, because if you're going to try to be replacing your SO2, you want to think about both that microbial and that oxidative kind of stress. This doesn't come out of nowhere. There are some papers in the literature that kind of talk about this. I found one set of papers that really did look at a bunch of different phenolic compounds. And what came out of those papers for me was that not all tannins have all of these functions, but some phenolic compounds have been shown to have some activity against some microbes. And so there is a real selective process to that. It's not just, oh, if I have more tannin in my wine, then I'm going to have less problem with this. It's very specific ones. And I would also say that at least these papers looked specifically at kind of the lactic acid bacteria, and just remembering that those bacteria have kind of different cell membrane and cell wall properties than what the acetic acid bacteria do. So when we kind of are looking at, are they having efficacy, we want to kind of remember that those are not all the same thing necessarily. I will say that they did have some kind of, this is one of the pictures that they showed when they treated with one of these phenolic compounds. The cells on the top are sort of healthy cells. They're filling out the cell. They're doing their work. You can see the cells on the bottom. Some of them are starting to kind of get ghosty and scrunched up. They think it's basically just blocking traffic on the cell membrane. But anyways, just to realize that, there is some literature on this, but again, how much that's going to work is we'll find out. So that what's in front of you, you can go ahead and look at the groupings here. So again, in your triangle test, you had two that were the same and one that was different. So you can determine which one was different. You can figure out if you got the answer right or not. We will go ahead and look at a little bit of chemistry first, and then we'll kind of talk about the sensory impacts. So when we look at the wine chemistry, again, we were able to kind of follow the wine as it went through its progression. This actually, for Cap Sauv, this came in with really nice chemistry, Lee. Good job. It was 2023, right. So we had a forgiving vintage that year. Good bricks, very low acetic acid at this point. But we were actually also able to look at the microbial population as well. So when a couple of things when we look at these microbe graphs, microbes, we tend to think about them in terms of kind of groups that are powers of 10. So this graph is a logarithmic graph, so that each line represents sort of the difference between one line and the next is 10 times more. The reason for that is that microbes, they tend to proliferate exponentially, so we graph them logarithmically. If that's too much math for you, you can completely forget it now, but that's why that's a log graph. The other thing to think about with microbes is, microbes are normal on grapes. There are microbes that are going to come in on your grapes. Generally, if they're like at 10 to the 2 or less, that's kind of a normal population. When we see spoilage in grapes, that's when we start to see them creeping up into like 10 to the 4 and even 10 to the 6. And that's when they start to kind of be more of a spoilage problem for us. So if we look at this particular group, we do see that Hanseníaspora did come up with a pretty high level there. Hanseníaspora is going to be the most common non-Saccharomyces yeast that's going to come in. And again, when we sort of have humid conditions like we have here in Virginia, it's probably not surprising that we have a fair amount of that. But we do need to look out for Hanseníaspora because it can produce high levels of acetic acid and high levels of ethyl acetate if it has enough time to work. So if it's It's got oxygen and it's got some time to work. So if you do cold soak or have a long lag phase, that's when that's probably going to become more of a problem, and some good protection is going to be needed. We also see a fair amount of, for example, Saccharomyces and Enococcus. Those are probably just coming in like they're on the T-bin, they're in the pump, they're in everything else. But we can also see the acetic acid bacteria here. It's not small. And so again, realizing that the Acetobacter is everywhere, it's ubiquitous, it's coming in on your grapes, and it's present through every part of the fermentation. It's sort of different members of that group sort of go through succession over time, but there's always somebody present. So in this case, you know, pretty healthy grapes, but we do still have some spoilage microbes in there that we want to take a look at. And again, that's just inherent to what grapes look like in Virginia. So when we look at the post-malolactic wine chemistry, and I will say that this wine was co-inoculated, so we didn't really have any time point that was like end of alcoholic before between alcoholic and malolactic. So we did look at post-malolactic. We can see that, you know, at this point, we do have a fair amount of acetic acid that has accumulated. So we're right at about that 0.7 mark for 4 of the 6 barrels. And again, this is before anything got any Hideki treatment at all. This is just post-mallow. And so in that case, I would just say a couple things. First of all, you know, this is a little bit on that higher side. So maybe there was some microbial growth there. And there's some things about this chemistry that would indicate we might have that. We have a little bit higher ethanols. That might stress the yeast a little bit. The pHs I mean, Lee did judicious acid additions, but I think we've all seen numbers like this where we finish mallow at about a 3.8. And again, that's just going to be a little more permissive for our microbes along the way. But the other thing I would point out here is, you know, you've got 6 barrels, 4 of them look like they're manageable. And then we've got these 2 other barrels that are a higher number. And I would say that, you know, for those of you that are managing multiple, like lots of barrels within the lot, you are taking your acetic acid numbers right at the end of mallow. Just be aware, because it went through mallow in the barrel, there could be different things happening in different barrels. So it is helpful at least to smell and taste every barrel, and maybe to run that number on individual barrels if you have the ability to do that. I do think the Sentia has made that a little bit more affordable to do that at least one time. In this case, they were kind of the highest number barrels. And so there's some hypotheses there. My hypothesis on this is that maybe they just were the ones at the bottom of the tank and got a little more microbial load. But Lee, I don't know if you have any ideas about what was going on what might have happened in those 2 barrels versus the other 4.
That sounds good to me. They all would have come from the same tank. We divide out our red wines through we have our barrels of free run, and then we also have pressed wine. So I don't remember if 6 and 7 would have been pressed wine or not. Yeah. But it could have been.
And in this case, they have the same. I mean, the pH isn't drastically different, and so maybe it's a little bit. No, it's about the same. So in that case, it's probably not as much of a pH difference. But the other thing is they were on the rack together. So again, when you have multiple different racks, if for some reason one rack gets missed in the topping, that might be another thing that happens along the way to sort of think about. But and then so if we look at sort of I'm sorry, let me back up. It was it's not letting me back up. I apologize for the technical difficulties. We'll see if we can get there. We go. Okay, so it's at this point for the post mallow. It was post malolactic that we actually treated with the tannin, and the reason for that again is that you don't want to do either of these treatments earlier because they do have some working against Enococcus, and so these are all post mallow treatments that we're talking about today. So when we look at the post-aging wine chemistry, so after our 3 barrels, in this case we chose barrels 3, 4, and 6 as our control, and 2, 5, and 7 as the Hideki, and intentionally we split up those 2 barrels that had the higher VA so that one was in each treatment group. So we can, and I'm just showing you kind of the chemistry that has to do with oxidation or microbial microbial growth. So there's a couple of things in our normal wine chemistry panel that might tell us something about oxidation. First of all would be the free sulfur. If we have more antioxidant in there, we might have less depletion of free sulfur. So we would expect a higher free sulfur. We don't really see that here. It doesn't look like it had any impact there. But again, thinking about the fact that Lee added 100 parts and then left it alone from February to December, we still had a really nice amount of free sulfur protecting and doing antioxidant protection just with the SO2. The other thing we might look at is the color hue, and that's just sort of whether it's reddish or if it's, if it gets more kind of orangey or red along the way. Hue is the ratio of the yellow to the red, and a higher number means that it's sort of more has more aged or oxidized character to it. In this case, the color hue is exactly the same, so we don't see any differences there. And then with the acetic acid itself, we can see that there continues to be barrel to barrel variation. But if we kind of look at the change over time in each of those barrels, all of the barrels were at about 0.12 grams per liter. Now, again, that's a little bit on the sort of on the high side of the range due to just chemical oxidation, and it was a little bit less than a year, but generally that's a pretty low amount of accumulation for the amount of time that you had. So in this case, what Lee was normally doing in giving it that good SO2 hit, I think you said you were topping like roughly once a month. Is that what your topping regime is? Yep. And then letting them sit in the cellar. In this case, it seems like the Hideki tannin didn't make a difference in those particular measures. But again, there was a fair amount of SO2 present, so it may be that it wasn't really that additional protection kind of wasn't needed because it was additional protection. The other thing I would point out is the molecular sulfur number here. Remember, molecular is the portion of our SO2 that's actually antimicrobial. And the number of how much you need in order to have protection, it really depends on the organism that you're talking about. A lot of times the literature will say like 0.6 to 0.8, which in our relatively high pH reds is really fairly impossible to get to. But there's some indication that keeping it above 0.4 does have some help for you. So in this case, because that SO2 was added at the end of mallow and not touched after, the entire aging period, Lee had molecular sulfur that was at least 0.4 or above. And so that was giving some additional protection that way. We were able to get some microbiology as well at the end here. And again, just remembering as we look at the microbiology, those same principles we talked about before, but also remembering that the wines were not racked after mallow. And so we do have sort of whatever microbial load was in there after mallow is still in there. The other thing I'll say is that we did use the scorpions from ETS. So that will give us both sort of living and dead cells. So what we're really looking at in this measure is what's the difference between the control and the Hideki. Now, again, we can see that there's big differences between barrels, but we don't see any consistent impact of just the Hideki itself. We don't see the Hideki, numbers being less than the control numbers. So in this case, we don't really see a big difference. But again, that might have to do more with the fact that there was also, really good ample SO2 along the way. Either way, this was, there was fairly limited acetic acid accumulation as we went through. But I would say that these are only the things that we can measure. There's also sort of parts of the oxidative environment in the barrel that we can't necessarily measure, and those would come out in our aromas and flavors. So that's where we want to get back to the sensory component of the wine. So that's where I'm going to stop sharing for a moment. I can execute the stop sharing. There we go. Sorry, this is all a new thing for me as well. So if you're able, this would be a great time, participants, for you to kind of put your cameras on, because I'm going to start asking you a couple of questions. So I do want to be able to see your lovely shining faces if I can. Here we go. Here we go. Okay. So my first question for you is, were you able to tell the difference between the wines? And what I'll ask you to do is maybe use the raise hand function. To see, were you able to tell the difference between the wines? If you were, then go ahead and raise your hand. Let's see, here we go. And Rebecca, can you, oh, maybe that's how I see it. Okay, there we go. Now I can see it. Okay, so let's see how many raised hands we got. We have a lot of raised hands here. Lots of people were able to tell the difference between the wines. So this is where I'm going to ask you the follow-up question. What was different? What seemed different between the wines? So at this point, you can either unmute yourself and just kind of tell me what you thought. If you're not able to unmute yourself, then you can go ahead and write in the chat. But
These have a lot of condensed tannins, and it comes off, I thought, adding a little dustiness to the finish.
To the Hideki one?
Yes.
Okay.
Yeah.
Okay.
I mean, that's
Yeah,
what
and again,
that's what they're noted for, and it comes out here.
okay. Yeah. And that is, I mean, you are adding tannin, right? And
Well, these are particularly aggressive tannins.
okay.
I got graphite.
Okay. Graphite. And that would be
Graphite
another kind of,
but on the obverse of that, I thought that the in terms of palate weight, that the control was richer, rounder, fuller,
mhm.
and it still had nice tannins. I mean, the tannin structure was still there. You still have a little bit of drying, a little bit of astringency for it, but the Hideki one seemed to be a little bit. I thought that it was thinner because of the alcohol component in it, but I'm not sure if that's the right way to put it or not. But I thought that they were a little bit, and thinner isn't the right word, but less palate weight would be more correct. is what I'm saying.
Okay. Okay. Other thoughts about the differences?
I was able to taste or smell more alcohol, I guess, on the nose of the Hideki treatment.
Okay.
Usually, it kind of smelled a little bit like methanol or even isopropyl alcohol, is what I would like jumped out at me, and that was the biggest difference between the treatments. I don't know if that had anything to do with maybe acetaldehyde or anything like that. What was that measured in these?
We didn't measure the acetaldehyde, but also, if anything, we would probably have less acetaldehyde in the Hideki treated one versus the not Hideki treated one. So, and a lot of times the acetaldehyde, we wouldn't expect any free acetaldehyde when we have that much free sulfur. The sulfur is probably binding all of it up. But it's still good observation. So,
Seems
Did we?
to me,
Was it? Sorry,
I'm sorry.
Bruce. Was it
I was just
11 people out of 31 that could tell a difference?
I can't, Rebecca, I don't know if you can see a good view of how
Yes,
many.
Some people have already put down their hands, but I think at most it was like 11 or 12.
Okay.
I thought it added also sort of a green note, changed the aromatics.
Mhm.
That's for sure.
Yeah, and it's interesting, the other experiment that we've done with this, Mathieu actually used it on sparkling wine base a couple of years ago because we were looking at ways to inhibit malolactic fermentation. And in that case, we actually didn't see any differences in the scores for astringency or anything like that. I mean, we kind of thought like, adding tannin to sparkling wine base, but it didn't seem to have that impact. But, there are ways that it like, there's additive effects with the phenolics that are already in there. There's, again, all of our sensory, it kind of does depend on the matrix that it's in. So, it's interesting that that was picked up here when we didn't have that picked up on the other side. Okay. Anything else in terms of either like, how about oxidation? Did it seem like there were any differences in sort of the oxidative properties in like, did one of them seem more oxidized, or they both? They seem very fresh to me, but again, we had that nice SO2 coverage on it, so I don't know if anyone else picked anything up there. Yeah, so AJ says she's with David. The nose was stronger on the Hideki, so I don't have an explanation for all of them, but.
I thought the same thing when I did the trial. When it said, what makes you pick, number 214, I thought it had more aromatics to it.
Yeah, and I had a little bit of a shift in like fruit character, which to me probably might just be a little bit of aromatics. So. Okay. All right. So keeping that in mind, let's go ahead and move on to flight number 2. And I'll go ahead and share again so that we can see. This is where I always wonder if it's going to work. Oh, success. Okay. So flight number 2 had much the same setup, except in this case, instead of Hideki, we were using Stab Micro M. So just, a quick bit about Stab Micro M. So Stab Micro M is both of these products were provided for us by Inardis. Stab Micro M is a Ketosan product. And, most of us have used Ketosan at this point. It's one of these additives that seems to have, every time you turn around, there's a new use for it. But it itself is a biopolymer. It's produced in a manufacturing process by the deacetylation of chitin. That chitin always comes from a fungal source if it's going to be added into the wine. But that manufacturing process does change. Certain different formulations can have different targets. And so kind of paying attention to what the company is marketing it for and where they're telling you to use which particular Ketosan product is kind of important, because there are different formulations along the way. At this point, it's sort of been, used in all phases of winemaking, from the vineyard through pre-bottling. It's got all kinds of different things. But, when it first came out, it was primarily utilized sort of as a curative additive for Brettanomyces. And at that point, you would sort of add the Ketosan, you would let it settle you'd give it sort of, I think it was 9 to 12 days or something to settle, and then you would rack off of it. And that's really because one of the ways that Ketosan works is that it leads to sedimentation. So it'll bind to the cell membranes of the organisms, and it'll sort of link them together so they form more of a particle and come down to the bottom of the barrel. And then if you rack off of that, you've essentially reduced your microbial population. But there are, but people kind of started to use it in a little bit more prophylactic dose. And that's really what we were starting to do here, is that, folks were starting to use this with a low level that was added that you weren't really racking off of at all. Now, there is a little bit of work in the literature about effectiveness here. Or actually, there's a fair amount at this point. But again, the initial work was really just showing that it did have efficacy against Brettanomyces, Enococcus, Lactobacillus, and sort of this racking off kind of function. Doesn't really seem to upset Saccharomyces too much. So if you do add it at the beginning of fermentation, it doesn't seem to slow down your fermentations. One study early on did look at its efficacy against Acetobacter, and it seemed to be limited. So it was some efficacy, but it maybe wasn't as great. At least that formulation wasn't as great as it was against the other the lactic acid bacteria. But again, I was able to find kind of one mention of this use as a preventative measure, basically adding it into a barrel that hadn't yet been infected, something that was then in the study inoculated, to see, does it sort of do anything to microbial growth? And it did seem to have some efficacy against both sort of the proliferation of the cells, and particularly sort of the ability of those cells. That particular study was Brettanomyces, but the cells to sort of produce their spoilage metabolites. So there's sort of hints that this is useful. And I will say, in the last couple of years, the Inardis package instructions have changed so that it's not just telling you the prevented or the curative portion. Now there is sort of a preventative rate along the way. And then the last thing I'll say about that was that we did end up using Stab Micro M instead of Stab Micro. I'm sorry, this should say Stab Micro M. And there's a little bit difference in that formulation. So Stab Micro M is the one that's usually recommended for if you want to use it in juice, but it's also recommended for sort of wines that still have some turbidity to them. If you're using this as a curative in wines that have been aging for a while, then Stab Micro is the recommended one. And again, that's just a little bit difference in formulation. But since this was being added immediately post-malo without racking, Inardis recommended that we use the Stab Micro M version of it. Okay, so jumping in then, if we look at the grapes themselves, again, Lee, good grapes. This was a good year. You came in with some nice good bricks. Acetic acid was very low. And again, the microbial load here was really quite low. So we didn't see much Hansenia spore or acetic acid bacteria. And again, Saccharomyces is going to be ubiquitous everywhere we go, and it's not a spoiler. So that's not anything to worry about at this point. We did have a little bit higher pH in this wine, and we did add acid both at crush and after, and when it went into barrels as well. So just trying to keep up with that a little bit. Even though in spite of that, we did finish fermentation with a fairly high pH. Again, pretty high alcohol wine. It was a hot, dry year. And we can see that, we did again have that kind of proliferation of acetic acid within the boundaries of kind of what's normal, but again, really getting close to that sensory threshold as well. And once again, of 6 barrels, we had 4 of them that did that sort of didn't seem to, or that were sort of still technically below that 0.7 threshold, if we take that as our threshold. Then we had these 2 other ones that once again just had a little bit higher value to them. So in this case, we did look at ethyl acetate as well, because we were thinking about that. And in this case, ethyl acetate's pretty normal at lower levels. It might even add to some fruity character in the wine. Again, the number that you start to worry about it, somewhere between 90 and 150, depending on the wine, it might start to have some impact. So we didn't see that in any of the barrels except the very last one. And in that case, it was just at the lower end of that. And then if we look post-aging, and again, so the Stab Micro M got added right at the end of Mallow, and was just there for that aging period. Once again, we see the average accumulation of acetic acid, which is really what we were trying to prevent here, was 0.12 in one of them and 0.13 in the other. So in both cases, again, we didn't see a big difference in the acetic acid accumulation, but it was still a relatively low acetic acid accumulation. So it might be that it does have this, it might have impact if you're sort of fighting with other things. But again, that SO2 hit's doing a good job for you, Lee. You still have the really nice free sulfur there. The molecular sulfurs are a little bit lower on this one, but again, I think that's because your pH is a little bit higher on this one. So, it's going to be hard to keep a molecular at that point. So once again, we don't see any big differences there. But when we looked at the microbiology, again, same principles here, but I would say, look carefully at this graph. Do you notice anything? In this case, our control barrels are in blue, and our Stab Micro barrels are in orange and yellow. And it's a subtle difference there. But if you look at it, we have lower levels of microbes in our Stab Micro barrels than we do in our control barrels. Remembering this is a logarithmic scale, and we sort of started with what we started with. Again, this was post-Mallow, so we had a certain amount in there. So this gives us a little glimmer that it might be having a little bit of an impact on the overall microbial community. I have one other way of looking at this graph. I took the average, but this one we were able to get the microbial numbers at the end of malolactic. So I took the average number of microbes that we had at the end of malolactic, and then I looked at the average between the 2 barrels for each of them here. And what we can see is that, for example, if we look at acetic acid bacteria, we did sort of have an overall increase in the population level or the density of cells of acetic acid bacteria during aging in the control barrels. We didn't have that increase in the Stab Micro barrels. Again, little difference, but the difference really kind of is there. If we look at the other lactic acid bacteria, the acetic acid bacteria, and even Brettanomyces, even though it's quite low, we see that same kind of pattern. So in this case, we can say, we started with a pretty high microbial load. That's what was there at the end of Mallow. Again, both the SO2 plus topping and the Stab Micro M did a pretty good job of controlling that population. But even with all that SO2 in there, we still see that the Stab Micro M had a little bit more efficacy. So if you are one of those people that if you're adding a lot of SO2 and you're still getting this growth, Stab Micro might be helpful for you. And if you're somebody who's maybe not using as much SO2, I think we at least get some glimmer that the Stab Micro might be giving you a little bit of efficacy here in that preventative dose, just sitting in the barrel over time. So once again, if we can kind of we'll go ahead and look and talk a little bit about the sensory impacts here. And I know I got a text last time. Shai is calling in, so I'm going to go ahead and read off the numbers for group 3 so that he can hear what those are, but the rest of you can see them. So group 3, Shai, 715 was your Stab Micro M, and the other two, 359 and 872 were your control barrels. So just like last time, I will stop sharing. Didn't do that right. There we go. Stop sharing. And if you're able to put on your camera, that would be great. And I'll start with the same question. If you please raise your hand if you were able to tell the difference between the wines. Let's see. There we go. Raise your hand. Let's see who we've got. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Any more that we're missing? There are many fewer people were able to, it looks like we're able to, oh, wait a minute, sorry. Rebecca, I don't know if I can tell the difference between the last time and this time. Can you count up how many people were able to tell the difference?
Yeah, looks like 5 people have their hands raised.
Okay, so many fewer this time around. So anybody that does have their hand raised, if the wine seemed really different to you, please let us know what was it that that was different between the wines for you.
Just from my notes, the treatment wine was showing a little more development and showing more fruit character than the other wines. I think that was probably the only thing that drove me towards that. On the nose, I think perhaps the oak was a little bit more muted on the treatment wine as well, or at least more in the background.
Okay. Okay. And I will say, you know, like all of our experiments, we do try to utilize barrels as similar to one another as possible, but especially for the sensory, sometimes this is coming from one particular barrel. So we do have barrel to barrel variation there as well. It's an imperfect system that way. So any other comments on the differences between the wines? It seems like from that response, at least we'll do the statistics, but it doesn't seem like we'll have significant differences. But anything else that we should point out in case we want to go back and taste that wine?
I was wondering if anybody else's Stab Micro M treatment was cloudy, or if that just was something that I.
Sorry, you might have just gotten the end of the bottle.
Okay, that's good. And well, I had a question while we're at it. How long was this wine on the Stab Micro before you racked it, Lee, or before we pulled it for the experimentation?
It would have been 9 months. Also February to December.
Okay.
10 months. I can't math good.
And did you decide to use the Stab Micro M because you had turbidity in the wine instead of Stab Micro, or because you had Stab Micro M? Both are valid.
I did what Joy told me to do.
Okay.
And
Yeah.
in this case, I did what the Enartis rep told me to do. So we talked to the Enartis rep and we said, you know, this is the situation. We aren't going to rack before, before aging. And when you add it, you know, you kind of, you stir it up. And so that makes for more of a turbid environment. So they recommended at this stage to use the Stab Micro M.
Okay.
Yeah.
Makes sense.
So we're coming to the close of our time here, but I did want to kind of point out one more thing, and it's going to be easiest to see this from a slide. So I'll go ahead and share again if it lets me. Here we go. Okay. So, you know, the other thing we kind of wanted to look at in the experiment was not just did these treatments kind of work well to fend off acetic acid accumulation, but that bigger question of where is the VA coming from? If we really want to identify critical control points for acetic acid accumulation, when is that happening? And again, if we sort of look here, we started with almost nothing, and by the time we were done with mallow, we were kind of close to that threshold of detection in 4 of the barrels, And in 2 of the barrels, we were above the threshold of detection. And we saw that kind of in both lots here. So I think, and Lee and I have kind of already done this year, is that, the next stage of this is really to zoom in on that period of time from when the fruit comes in to the end of alcoholic fermentation. And then this year, as soon as Lee's wine, a set of Lee's wines were done with alcoholic, we actually tested the acetic acid kind of, I think, weekly and then kind of bi-weekly as we went along, as a way of just saying, like, if we did want to get this number down, does that number give us a clue as to where we might want to be having some interventions? And so we don't have those numbers all done for you yet, but I will say that, acetic acid is kind of a good one in the sense that we are able to measure that. So the next stage is just to do the measurements at these critical times to say, are we seeing this accumulation during alcoholic fermentation? Then maybe we need to look at yeast health and non-Saccharomyces yeast. If we're seeing it during mallow, then maybe we need to look at some of the components of what's happening during mallow. And so that's kind of the next stage. And I would just invite any of you, if you have specific lots that have this problem, or if you kind of overall want to take a look at it, that is something that I think the Research Exchange would be really happy to help you, just to, again, just be able to identify where those problems are. And then the other thing that's happening this year, and Rebecca is taking point on this, is really looking at some of our hygiene practices. We've borrowed a luminometer from Virginia Tech that allows Rebecca to go around and look at your cellar, swab specific places, and just look at your cleaning protocols to see if our hygiene practices are really having the impacts that we want them to have. If you're getting the outcomes that you want, then it's great. But if you are struggling a little bit with some of this acetic acid accumulation, those would sort of be 2 of the things I think we would be very available right now to be able to start looking at things. So Pete just piped in or wrote into the chat. He'd like for us to talk about barrel cleaning protocols. Has anyone measured the efficacy of getting rid of Acetobacter? Yeah. So Pete, I feel like barrels is like a whole nother topic. And I will say that Rebecca is doing some work on doing some specific measurements in Virginia cellars, but there has been some work looking at comparing barrel cleaning protocols as well. And actually, Rebecca has a really great table for that. So in the next couple of weeks or maybe sometime before Eastern Wineries, we'll put a bunch of information on the website so that you can look at what those comparisons really show. I don't want to talk about it off the top of my head because I don't remember all the details, but those do exist, and we're happy to send you to the papers for those. Okay, so just with regard to this particular project, is there anything else that anyone wants to say in terms of the sensory properties of this? Or if you yourself have experience using these, if you've had kind of good or bad experiences with either one of these products? Okay, Rick also wants to think about storage. You guys are just you're leading into things, so we definitely, like I said, Rebecca's been working hard on that, and that will be upcoming material to talk about these cleaning protocols, and particularly with barrels. So stay tuned on that for sure. Any other comments or questions about Stab Micro or Hideki or other aspects along the way?
I would just say that, in the early days, the real name of the game was trying to bring in clean, sound fruit, which is that issue hasn't abated, of course. We did try 2 things that I thought were interesting. We didn't pursue and we didn't get funding. One was SO2 spray in the vineyard, which is interesting, although not clinically legal because sulfur dioxide is not a approved vineyard additive. But it has some efficacy, particularly if you use low pH water in the spray and the price is right. The other thing that was equally intriguing and may have more viability was ozone spray. And I think both of those could help cut down the saprophytic load to allow, particularly when we have less than spectacular seasons, to allow us to gravitate to bringing in the cleaner fruit.
Yeah. Yeah. And Rick says it works for sour rot. Rick, I think are you talking about SO2? Yeah.
Yeah, that's actually what motivated both of these efforts on our part.
Yeah. Yeah. And Melanie has a question. Lee, after kind of doing all of this, would you use either one of these products in your regular protocols?
I am interested to continue checking them out. Yeah.
Okay.
I think that depending on the chart or the graph that you look at, you're either convinced that the stuff is snake oil, or you could say that, oh, there's really a big difference happening. Like the amount of acetic acid maybe didn't have a huge shift one way or the other, but if it's knocking down populations, I think it could also be beneficial to what your end goals are. So this is something that I would try both of them again.
And I think, getting like to that idea too, it's like you read the product literature and yeah, it's going to solve all your problems. But, and then sometimes it doesn't always have the efficacy that you're looking for. But I would also say that, anytime we're talking about microbes, I think, one of the things that a lot of times people will talk about is just sort of having multiple hurdles in place. You don't really know exactly. It's not necessarily that one of them is going to cure all of the ills. There's a lot of genetic diversity in the microbial populations that might be trying to ruin your wine. And so I will say that both of these work on a kind of different mechanism than what, for example, SO2 is working on. And so if you do feel like you have a difficult lot that you're really struggling with, or your regular protocols aren't really giving you enough protection, it is helpful to have something with a different mechanism of action to piggyback on top of what you're already doing. And so that's another thing too, is that it might not be the right thing for every lot. You might not need it on a lot of your lots, but there may be those lots, like your long aging Cabernet Sauvignon, that potentially could benefit from that kind of thing. So.
Yeah, I would also kind of just add on to that while I'm still interested in these products, obviously the biggest accumulation of VA that I had in these two experiments was during fermentation. And so I might be interested to find out more about what products are available for earlier in the life of the wine, from crush through fermentation, and onward. I'm also probably more interested at this point in doing co-inoculation, which depending on the year and depending on stuff that I'm working on, sometimes I do and sometimes I don't. And I think that the sooner you can get through mallow, probably the better for wines, has been my experience. And I know that you can have conversations about whether or not co-inoc might actually create some VA problems or not. And I think that could take up all afternoon. But also, I do think that in 2023, our fruit, like many of yours, was really great coming in the door. And it was just one of those years, like some other that we've had, where good wine just makes itself. It just, even with elevated VA numbers in some of these wines, I still feel like they are solid wines. The challenge that I run into every year, being a 5,000 case, 5 to 7,000 case winery, depending on the year and depending on clients' needs, is that I'm doing this on my own. And we also have 24 wines in the tasting room, which is a really dumb thing to do. And so I think probably the best thing that I could do for VA accumulation is to hire an assistant. And so when you are actually able to put the time into making things are done properly, as opposed to, oh gosh, it's time to go pick up my 9-year-old from school and just abandoning everything on your way out the door, like that's not how good wine is made. And so I think that has been the biggest challenge for me. If I can find some products that might be something that aids us in still meeting our end goals, I'd still be interested in that, though.
Yeah. And I think that's an excellent point, that there's no substitute for good practice. And there is a reason that we have these things baked into our winemaking practices to top regularly and, to test mallow so that when it's done, you add your sulfur on time and those sorts of things. But then there's the realistic part of that too, to realize that we're all working in maybe less than there's resource limitation in a lot of places. And so in these places where you could have a little bit of, an extra barrier or an extra kind of level of intervention, sometimes that's a good option as well. So one thing I wanted to say with regard to Koenig, there's something came up with Koenig. We did do, we had a discussion last year. We had a project with co-inoculation that was really a data only project, but we did do kind of a video about that. So if you want more information about co-inoculation, that's on the website. But then there's also what is it? Lactobacillus plantarum is a selected strain of Lactobacillus plantarum called ML Prime has recently been added to the Scott Labs catalog. We have one project with it this year. Corey Craighill did that, and we'll feature that in an upcoming session. But Lactobacillus is a co-inoculated malic acid bacteria, but it's thought to have less volatile acidity accumulation. It's thought to be more have better efficacy in actually getting your co-inoculation done. And it also has less diacetyl production. So that's one, again, for anyone on the call, Lee included, if, this year it was under provisional use from the TTB, but we anticipate it will be approved very soon. And so if anyone's interested in doing projects with co-inoculation, specifically with Lactobacillus plantarum, we would love to talk to you about doing those projects for next year. So, Emily, you raise your hand.
I was volunteering to do that.
Oh, you were volunteering. Okay.
Yeah,
Yeah. You just signed up.
I wanted to do it this past year, but we didn't get our letter until everything went fast this year. But I'm really interested, just like you, Lee, to close the gap on the fermentation and pre-ML finish accumulation of VA. So that's where I'm working.
Yeah. And Rick, you've got your hand up? Are you volunteering also?
Yes, actually, I'm volunteering also, but I also have a question is, when we're saying co-inoculation, is that basically the same as sequential inoculation for ML?
No, this would be that you would add it, basically you would add your ML bacteria right around the same time that you're inoculating for fermentation, just slightly after.
All right, well, I would like to try the
Great.
I will say that I've been paying a lot of attention to VA as time has gone by vintage, and I've had pretty good success with lowering my VA numbers with sequential ML inoculation. So basically, I wait until I have a minute when everything's less than like 3 bricks, and I just throw a bunch of bacteria in the bins. I mean, it's not quite like that, but I do. Thank you, Lee. I see you took it the way I meant it, but if I have a minute where it's like less than 2 bricks or almost done with alcoholic fermentation, I will methodically add the correct amount of ML bacteria, and I've found that over time, particularly the past 2 vintages, my VA numbers have gone down in finished wine. Yeah. So.
I would say, we'll have to have a longer conversation. Maybe when we talk about Corey's project, that would be a good time for us to talk about different strategies, because there is some danger in having ML happen when you've got some sugar around.
Correct.
So there's some reasons to add it like at the very beginning or at the very end, but not add it in the middle. And so that's a longer conversation. But I love that we've already started that. And speaking of having to get your kid off the bus, we do need to make sure to I want to make sure to thank Lee for his project today. Lee does have to leave at 2:30 to get his kid off of the bus. Thank you so much for doing this project and for sharing your wines with us and helping us to kind of think through all of this. We really appreciate that. We also want to make sure to thank Enardis for helping with things. They gave us some good advice on how to use these products properly. They also donated products to this to the project itself. Of course, there are many different products that you can find along these lines. So feel free to shop whoever your favorite manufacturer is. And also we want to thank the Virginia Wine Board, of course, for continuing to fund the research exchange. And thanks to each of you for sort of doing all of your sensory evaluations. That becomes data for us, and that's important feedback for Lee and also for folks that didn't get to taste the wine. So we'll say goodbye to Lee. Thank you so much. I will stay around if people want to continue to talk. I have probably another 15 minutes before I have to hop off. So if we have additional comments, we're happy to take those. So